Il y a 6 minutes, il y a 8 minutes. Ouais. Okay, you can start? Okay. So, hello everyone. Thanks for being here. We'd like to thank Blender Foundation for giving us the opportunity to give this presentation. Okay, so my name is Christophe Poirel, and here is Romain Lopez. We are both ESGAI students. It's a French IT school, and we are both in Master of Computer Graphics and Video Game Engineering. So we are presenting our auto-rigging method. It's based on raycasting. And we will present the method first, and after that we'll have a quick demo of the Blender plugin. Okay? So, okay. So just for the beginning, what's rigging? Actually, rigging, to do it quickly, it's putting an armature skeleton inside a body, a mesh character, to animate it. And to do it, we move the bones, and the character will move also automatically. So auto-rigging is doing this automatically without any human intervention because it's long and it's painful. So the idea is to do it automatically. Works have already been done in this area. We have Frankenrings, which is based on a database of body parts to find different limbs. We have also work that has been presented at HC 2010. It's based on a shrinking mesh to find the skeleton. And maybe the most famous work has been done by Baran and Popovic. It's called Pinocchio, and it's based on discretization of a mesh. So our method is different. It's in two parts. The first part is a 2D mapping of the character to find the limbs. And the second part is a 3D recasting to center the bones inside each limbs. So during our work, we've been working with Blender and Python for scripting language. So Romain will explain you the first part.
So as Christophe said, we're going to put this armature into a human mesh. So you can see that there are legs, arms, head, and torso, and we have to identify this part on the mesh to fit one into the other. So it's really easy for any human to identify this part into this mesh, for example. But from a computer point of view, it's just a 3D point cloud. So our first step of our algorithm is to simplify the mesh. And to do this, we are both to simplify the mesh, we will first create a 2D projection using a grid in front of the mesh. We will raycast through each hole of the mesh and keep the intersection point and put all these points in the same plane, and we will have this shadow that we call silhouette. And you can see that one of these requirements to have a complete shadow is to not have any limbs crossed or hidden behind the silhouette. So now that we have what we call the silhouette in the grid, we can outline it. And we had previously a 3D point cloud. Now we only have a 2D point cloud, but the remaining points are all what we need to identify the legs, the arms, the head, and the torso. So we are going to start using this point and find the limbs. So we're going to state that the lower slice, because it was on a grid, so it's by slice, we're going to state that the lower slice with 4 points matches the legs, and we will have the outer right legs, the inner right legs, the inner left leg, and the outer left leg. To ease future computation, we are going to store for each point which is its next point and which is its previous point. So we can go through all around the silhouette like we can do it with our finger if we wanted to draw it. And we are going to do it according to 3 paths. We will go from dark blue to soft blue. So there will be one path around the shape like this, another one on the other side, and one between the legs. So what is it for? There is a lot of material stealing here. Beware of your stuff. So what is it for? Well, for example, we can go using the middle path. We go through the inner legs and stop at the highest point and say this is the area we will call the groin, and we will go now on the 2 other paths and stop at the same eye and say we have now found the legs. So we'll remove the legs from the silhouette, and from the remaining points we will say that from now on the X max and X min will be somewhere in the arms because there is no more legs. So unlike you have like gigantic ears, they will be in the arms. And the point who are the next point to the hip, the next point to the last outer leg points are in the hip. So we have here something in the arm and 2 points in the hip. And we are going to find the armpit. So to do this, we want an inner arm point, a point that is not like that, but really inside the arm. So we are going to draw a line between the hip point and the random arm point we have found. And if the line intersected a point, we're going to take this point as an inner arm point. And we are going to find the armpit with this. So we have a line and an arm point. And what we will do is that we are going to increase the b in the line equation. That is to say, we're going to make the line go up and up and up. And every time we are going to stop and try to find the new closest arm point going from previous to previous point. It's like, if this was a drawing, it's like drawing inside the arms, line like that, until you reach the armpit. And this is the point that it gave us. At one moment, you make the line go up again, but it can't find any better point than the one he had before. So this point will be named the armpit. And we will remove all points from hip point to armpit and say that this is a body. Then we will do something that looks like what we did for the legs. We'll go from next to next point and say that all points crossed until we reach the same X as the armpit are the arms. So only remain these points, and they will be called the head. So here is an example of body mapping from this 3D point cloud, which a different color for each limbs. So we now have the identification of each limbs in the mesh. How do we place the bones inside? Christophe is going to explain you this step.
Okay, so from the previous algorithm, what we have is different limbs, or in a 2D space. And now we're going to use it to find some entry points. So by entry points, I mean in the next algorithm we use, we're going to use these points as start points and stop conditions for the algorithm. I will give you an example with the arm. So if we take the arm and the entry point we have found with the previous body mapping, this point will be the point where the algorithm will start, and here the armpit will be the stop condition. I mean, the height of the armpit will be the maximum height that the algorithm reach. So what's the algorithm actually? It's the idea is slicing each limb. So here we are going to slice the arm, and to do this, we're going to use the entry point and cast rays 360 degrees around to find the intersection with the mesh. And when we have this slice, we're going to find the center of the slice to have a candidate to place the bones later. So let's see what is inside. So here we have all these points who represents the intersection points with the mesh. From a more schematic view, here we have in blue the slice, the mesh. It's the slice of the arm, and the green dot is the entry point. So what we are going to do is we are going to cast some rays 360 degrees around and keep the intersection points here to make a polygon. And now we have to find the center of this polygon. And the simple way to do this is to use a barycenter. So we just have to put some weight, specific weight for each point. And we decided to do this by using the distance to the closest neighbor. So for example, if we take a point at the top who is far from the other neighbors, this point will have a strongest weight than a point at the bottom who is really close to its neighbor, who has the lightest weight. So that's why the circles are smaller. So now we have the center, and we can go step by step downwards the arm. So what we do actually is that we found the center, we go down a little bit, we found the center, and we do this until we stop. So we're going to have a view of the side to see what the stop condition here is. So here, if we go down, we see that at the moment we will reach the outside of the mesh. So there is no more need to do some recasting here. We are outside, so it's our stop condition. And now that we have done the low part of the arm, we can do the rest. So here it's important to see that our rigging stops here inside the hand. We did this because there is no hand rigging. There is no rigging for the fingers, because the BVH we have been working with have a unique bone for the hand. So we didn't focus on this.